Alright, so now again we just finished our first problem for test 3 grade replacement. Again, my name is Alex Berry. We're now doing problem 6.3.9. This is a tough problem. Let's actually look at what we have to do. They give us our bounds of x equals y squared and x equals y plus 2. We have to use the shell method to find the volume around the y-axis. So our keywords are shell method and y-axis. So in other words, we're going to be rotating in terms of dx, and we're going to be going this way because it's around the y-axis. So this is kind of tricky, so I need you to follow me. So since we're rotating in terms of dx, we have to get all our functions in terms of x. So right here we split up the x equals y squared, made that into x equals plus or minus root x, and then x equals y plus 2, we just make that y equals x minus 2. That's pretty simple to follow. If you don't get that, then you need to stop watching the video and go ask for help. So then we need to find a point of intersection between these two graphs. So we set root x equal to x minus 2. You can set root x or plus or minus root x. It doesn't matter because when you square both sides, you just get x equals x squared minus 4x plus 4. Move that over here. Factor it. Find your roots. So now x equals 4, x equals 1. Bam. So these are our points where the graphs intersect. So now if we come over here and we draw it really quick, bam, that's what our graph looks like. And we are trying to integrate from, and my points, my x-axis is a little off, but basically we're looking for this region. The volume of this region rotated around the y-axis. So a slightly better depiction, sort of, is this graph over here. And you notice this top curve is root x, this bottom curve is negative root x, and then this line right here, let me redraw that to make it a little neater. This line is x minus 2. So we're integrating this region around, again, the y-axis. And so actually, and remember our bounds were from 1 to 4. So let me actually go and erase this. Erase some of this stuff too. It's kind of cluttered, I know, I'm sorry. Just stay with me here. So we're integrating from 1 to 4. So now this isn't really that bad. Our basic volume for shell method is going to be the integral of 2 pi from a to b of, since we're in terms of x, it's going to be x times whatever your height is dx. So in our case, our h is just going to be your top curve minus your bottom curve. Okay? And if you look at this graph, our top curve is root x. So h equals root x, and our bottom curve is just the line x minus 2. So root x minus 2. So now we found our h. We have h equals root x minus x minus 2. So that's going to be this part from 1 to 4. But we also have to remember integrate the part from 0 to 1, right? So that h is going to be the top curve, root x minus the bottom curve, negative root x. So that h is going to be 2 root x. So that means we're going to have to have not one, but 2 integrals. So here we go, let's moonwalk over this part. So our volume is going to equal the integral from 1 to 4 of 2 pi x times root x minus 2 dx plus, and here, this needs to be a 2 pi right there. I know it's kind of hard to see. Times the integral of 2 pi. And actually, messing up all over the place today. should be from the bound 0 to 1, integral of 2 pi x times 2 root x dx, and it's 2 root x, remember, because it's top curve minus bottom curve, root x minus negative root x. Now we just go to integrate this. So starting from the left side, v equals, we're just going to factor 2 pi out of our integral here and our integral here, so 2 pi. Right here, this is the same thing as saying x to the 3 halves minus x squared minus 2x. So when we integrate that, that's going to be x to the 5 halves divided by 2/5 minus x to the 3rd divided by 3 minus x squared divided, or actually no, not divided by 2, because that 2 and this 2 would cancel, that's just x squared. And that's from 1 to 4. And then over here, that's going to be plus. And remember, all of this is going to be times 2 pi at the very end. So plus, this is the same thing as saying 2x to 3 halves. So when you integrate that, that's going to be x to the 5 halves. 5 halves. And then that's divided by 2/5, or sorry, times by 2/5. So 2/5. Can you see that?
Hello, Brooks.
You put the little line.
2/5.
Alright.
So you're with me there, so I'm just going to simplify that. Oh, drop my marker. I'm just going to simplify this to plus 4/5 x, right? To 3 halves, and that's from 0 to 1. So we're almost done here. You should be with me up to this point. If not, go back and rewatch this stupid video. So here we go. We're going to go work from left to right. So v equals 2 pi, oh sorry, let me close this off with brackets. So remember that 2 pi is going through everything. We're going to multiply everything by 2 pi at the very end. So 2 pi equals, plug in 4 for here. So 2 times 4 to 5 halves. Divided by 5. 4 to the 5 halves. That's the same thing as 2 to the 5th. Right?
Yeah.
Yeah, 2 to the 5th. So that's just going to be 32 minus 4 cubed, that's 64 over 3 minus x squared, so 16. And then all of that plus
Minus.
thank you. Now we put 1 into here, so that's just going to be 2/3. 1 minus 1/3 minus 1. And again, plus our other integral. So if we put 1 into here, that's just going to be 4/5. Put 0 into here, that's just going to be 0. Alright, and then our brackets to end it. 2 more steps. 2 more effing steps. So now our volume equals all of that, so now we have to do is simplify. So I'm going to erase some of my earlier work for board space. So I'll erase my graph for board space. If you need to see it again, just go back to an earlier part in the video. Alright, so starting up here, our volume is going to equal 2 pi times 64 over 5 minus 64 over 3 Thank you, Professor, for giving me such excellent numbers to work with. I'll subtract, so if we did 2/3 minus 1/3, that would just be 1/3. 1/3 minus 1, that would just be negative 2/3. Negative 2/3 times a negative, so let me write that right here. So that would end up being negative times negative 2/3, which just equals 2/3.
Plus 2/3.
Hmm?
Plus 2/3.
Sorry. It should be plus 2/3. And then over here, that's just 4/5 plus 0. It's just 4/5, so plus 4/5. And now, we're just going to simplify this all in one step. So this simplifies to. So now our final step is our final simplification. And this is going to equal, when we solve all of this out and use our awesome mental calculator, this equals negative 144, negative 144, 9.3, negative 144.9321411. Okay, so now our last step. Notice we got a negative number for this. You can have volume in negative terms, but for our purposes, we're just going to change this. So we're going to do the absolute value of this number. So our final answer is volume equals 144.9321411. This is our final answer. Again, this is a 4. Alright?
Alright.
There we go. Done.